What's up, Internet, and welcome to part 10 of my Niagara Program tutorial series. In the previous lesson, I showed you how to create and write to a CSV file. So what's a good scenario where that would be useful? Well, in my career, I've found that there are a lot of bigger organizations out there that do asset tracking. They've got an inventory system for all their JASes and edge devices and etc. So I've been handed a task of retrieving data from these. And it's not necessarily data that's you typically pull into a web supervisor. So there's something like a serial number or statuses on Wi-Fi or USB statuses, whether they're enabled or disabled. A lot of information that is accessible locally at the device, but not necessarily accessible in the web supervisor it's brought into. So you get asked to retrieve something like a serial number on 3,000 devices. I'm sorry, but I'm not logging into 3,000 devices individually and getting this, or I'm not going to 3,000 locations and retrieving this information. So instead, I'm going to use a program object to get it. So in my environment here, unfortunately, I've just got a couple laptops that are running stations, and then I've got this pulled into a web supervisor on another machine. So I basically got 3 machines here. And I don't have any JASes deployed in my little development environment, unfortunately. But I can still use the same concepts to pull data from these Windows platforms. So if I go into my platform service and go to the property sheet, I can see here I got some data I can pull. So let's get down here and figure out something I can pull. So I can get the Niagara version that's running, which that's easily found in the Niagara network, the station object in the Niagara network. But something like, I don't know, current CPU usage or the number of cores on the CPU, the memory, stuff like that I could get. Like I said, that's stuff that's not necessarily brought in through a proxy point. So in this video, I'm going to show you how to grab all this stuff from remote devices and print the output to a CSV file. All right, so picking up where we left off in the previous lesson, I've already got my file creation and my file writing code written. So basically, I just need to provide it some new content to write. And the first thing I want to do is I'm going to create a slot called station query. And that's going to be a query of all the stations in my Niagara network to run this program across. And just like before, we're going to create an empty station here, and then we'll resolve it and get the results back to a table. And then we're going to create a cursor for that so we can iterate through it. And then all the rest of this is just for my file creation. So we get down here, and I'm going to be writing the output in a CSV format. So I want to have a header with different columns. So I'm going to do a column for device name, IP address, version, operating system name, CPU percentage, CPU cores, and fault. And the fault is going to be, let's say I run across a device that's offline or disabled, and it's not going to be able to retrieve data for me. I'm going to indicate the fault here in this column. And after we write that, we're going to write file writer append, and we're going to pass it this, which is a new line. So every time this runs and it starts a new file, it's going to throw our header in there. It's going to skip to the next line, and then it's basically going to wait on us to give it some new data to write. All right, so I'm going to do a while loop and iterate through my BI table that was returned from my query. And the first thing I'm going to do is I'm going to call job.heartbeat. So what this is in our B job, which extends my task here, we have a method called heartbeat. And what that does is it updates the heartbeat time so that we know this job is still alive and kicking. So every time we iterate through here with our while loop, and it's going to a new device that we return from our BQL, it's going to update this heartbeat and let us know that, hey, we're still working. All right, then I'm going to call my station equals the current cursor.get. So basically, wherever the cursor is in my table, there's going to be a station object, and the cursor is going to be equal to that. And so the station is going to be equal to the cursor. All right, so one of my columns here is going to be my address. So I'm going to create a string address, and it's going to be station.getAddress. And then I'm going to cast that to a string, and I'm going to get rid of the IP colon. So the IP address will return an IP colon, then 192. Whatever. So I'm going to get rid of the IP colon. So I'm going to do that with substring. And that's basically saying when you return the IP address, so for instance, it's going to be, I'm going to skip past the first 3 indexes of my string, and I'm just going to return just this. All right, so what if a station is down or disabled? So if it's down or disabled, I'm not going to be able to get anything from it. So we're going to put in a file writing clause in here saying that if the file is, or if the station is down or if it's disabled, so if either of these come back true, so if it is down is true or is disabled is true, we're going to write the name, station.getName, and then we're going to do plus a comma, then we're going to do plus address, and then we're going to do these commas, and then we're going to do the station.getHealth.getLastFailCalls. So we have to put these commas in here to make up for the empty rows that we're going to have. So you notice if this station's down, my address is already in my station because I couldn't connect to it if I didn't have an IP address. Station.name, I can get the name from the local station here, but I can't get the version. I mean, I can, but I'm getting it from the actual remote device itself. Obviously, I can't get the OS name, CPU percentage, and the cores, but I can get the fault, I can get the IP address, I can get the name. So we got to put in provisions there that those strings are going to, or those columns are going to be empty. And then once we do that, we're going to do append, and we're going to skip over to the next line. So if else, if the station's not down, we'll go ahead and log that the station is online. I guess up here we could do a log as well. We could say job log.failed. And we'll go station.name, and we can say is offline. Do something like that. All right, so to make a direct connection to a subordinate device, first thing we'll do is we need to give it the parameters to make the connection. And basically what we'll do is we'll make a copy of the current connection we've already got with it from our Niagara network, and we'll just pass that to it. So in this case, the connection is made over a Fox client connection. So we're going to create that object. We'll just name it CX for connection. And then we're going to do station.getClientConnection. And that will return our Fox client connection property. Once we have that, we can create a session. And when we create a session, we need to pass it some parameters to start with. So in this case, we're going to do the make method. We're going to pass it station.getRemoteHost. We're going to pass it our port, which would be 4911. And then we'll pass it whether or not we're using Fox S. In this case, we are. And then we're going to pass it the credentials that are being used in the active station connection here on our network, in our Niagara network. All right. Before we make the actual connection, we need to create a string and call it interest. So the interest is basically, if we look here at engage retry. So when you make a connection, there's a couple different methods here. So you got to engage retry and you got to engage no retry. So that means if you make a connection and it fails, this thing is just going to sit here and keep trying to connect to it. And we don't want that. If we make an attempt and it fails, we want it to just stop. But you need to pass it a unique string for that connection. So like we make the connection, we pass it a unique string representing that connection. And then so later when we get done with it, we can just call that same reference again and just tell it to disengage. So in this case, our unique key for this connection is just going to be the string int, and then we're just going to add the current milliseconds to it. Clock.time.get milliseconds. All right, so if our session is not null, so if we've got a session object here with the correct information passed to it, we're going to try to make a connection. So we're going to do session, engage, no retry. We're going to pass it our unique identifier here. And as I said before, if we do engage no retry, that means if it makes an attempt and it fails, it's just going to stop. Whereas the engage retry means it'll sit there and continuously try to make a connection, and there's eventually a timeout, but we're not going to go that route. All right, so then we're going to log a heartbeat saying that, hey, we're still working here, and we'll make another message log. We'll just say, hey, we're connected to the device, and I'm going to create several empty variables here that we're going to be using later. So the first one's just going to be version. Second one will be the OS name or the operating system name. Then we've got a integer for CPU percentage because it's going to return a 0 to 100% or a 0 to 100. And then we've got a core count here, which is going to return how many cores the CPU has. All right, so we're going to do another try. And this one we need to resolve where we're going to get our data from. So we looked earlier and we saw that we're going to get data from our platform service here. And platform service has a system service. The type is platform, system platform service, Win32. All right, so we need to create our reference to the location. We're going to use a BORD and we'll just name it remote ORD. And then we're going to make it the path of the system service. So if we go here and it's located under platform services. So that's what we got our string here. So we need to create an instance of a platform service Win32, and then we need to resolve it to this location. That's what we're going to do here. We're just going to call it plat service, pass the type, and then we're going to resolve it. All right, the next line we call is a lease. So when you create a proxy point from a remote station, it subscribes it. So that means that, as long as that point's subscribed, it'll always pass up a new value to the web supervisor you've got it pulled into. So that's a state of subscription. So there's also a stateless subscription, and that's called lease. So basically, if you're leasing something, you pass it how many children or how many levels of children you want, and you could also pass it a time for how long you want to get it. Niagara's got a default, I think it's a minute. So if you just pass it how many levels, you don't have to pass it a time, or you can pass it whatever milliseconds if you wanted to. But in this case, so I'm saying that I want to lease this platform service, which is this, and I want to get just 2 levels down. All right, so I'm going to call plat lease, and then we'll say 2 or 1. We could do 1 as well as the level of children we want. So we'll go back here and go to the property sheet. We've got our system service. Let's say if I had, I don't know, if I wanted to get this, the file attributes or something, we'd have to go 2 children down. We'd have to request 2 children or 2 levels of children. So it'd be, here's the parent. This would be the first level. This would be the second level. In this case, these are the attributes I'm trying to pull. So we're just going to do a level 1. All right. So once we've got our system service resolved, we can start retrieving data from it. So in this case, we're going to take our version string here, and we're going to get a platform service.get Niagara version. These are all the properties that I can pull from. So in this case, I want to do Niagara version. So I'm getting Niagara version property, which is here. And then I'm going to get the OS name. So I'll call plat service.get OS name. And we see we got the OS name right here. And then I'm going to get the current CPU percentage. And go back here and see we have a current CPU usage property. And then last, I'm going to get the number of CPUs, which I call the core count. And we've got the number of CPUs property here. All right, so we got our data, and we've got it sent to our variables here. And then we need to start dealing with these try catches. So when we call resolve.get, there's a potential for an unresolved exception to pop up. So we're going to take care of that guy, because I might be calling for something that doesn't exist here. So we always need a catch for that. And then once we've retrieved our data, we'll log that we successfully retrieved the data. So now we have the data. We actually need to write it to a line in our file. So we'll call filewriter.write. And then just like before, we'll concatenate all these variables and values together. And then we'll call the filewriter.append, add a new line to it. And we've got one more exception here. This is just a general failure exception saying that if our connection couldn't be made, then we'll log it, and then we'll do similar to what we did before, whereas we'll fill in what columns we can, and then we'll leave the other ones blank. And then we'll go to the next line, and we'll print a stack trace out. And then our finally clause here, we're going to disconnect our session. So we'll call session disengage, and then we'll pass it our unique identifier here. And then going back to our if up here, if the session is null, we'll just print out the line saying the session is null, and then we'll append a new line to it. And then we'll be done with our cursor, so we'll close it. And we've got one more catch here we have to deal with, so we'll just print the stack trace out on that guy. As before, in my finally clause here, I'm going to close out the file writer if he's got nothing else to say. And then another exception here we need to print out in case there's an issue, and then we'll close out our job with an ended task message. All right, so if all is well, if I run this, it should give us a file with some information in it. So let's see what happens. We got a success here. Job log is showing that we created a file. It's saying that the first station is online. It says connected to the device. It says we retrieved the data. It skips over down to the next device. Same thing. We ended the task here, and the job was a success. If we go into our file, we'll see that we've got some valid data here. So if we take this and we create a new text file, save it, change the extension type to CSV, we open it up, and here we go. We've got a valid CSV file with the information we pulled from the endpoints. So as you can see, if you had to pull a bunch of information from a bunch of devices, you can possibly do that with the program object, and you can print it out to a CSV file. Obviously, if I had some JASes or some edge devices, I could get a lot different data here. I mean, I could get pretty much anything out of the system service on any device. So pretty much, as I said before, information that's not typically brought up through a proxy point. So that'll wrap up this one. If you got any questions or comments, just drop them below, and we'll catch you on the next one.